Hello everyone, my name is Oleksii Mykhailenko. I am going to talk about power consumption control of multi-pump systems of the main water drainage in underground mines based on the Mamdani fuzzy inference system. Creation of the power market in Ukraine has resulted in radical change in principles of mutual financial settlements between distribution operators and consumers. Dynamic pricing in determining power price has provided ample opportunities to develop new algorithms for controlling power supply and consumption in power systems. The research aims to synthesize a system for controlling power consumption levels by electromechanical equipment and mine water drainage facilities. This power control system can be represented by a mesostructure with two input, water inflow and power cost, and the one output, the power of pumps variables. Moreover, all three coordinates are subject to expert evaluation. As a result, it is advisable to develop a smart power control system for main water drainage facilities using the Mamdani fuzzy logic inference algorithm. The synthesis of fuzzy control system for power consumption by main water drainage facilities as part of mining enterprise can be clearly demonstrated on the example of Kryvyi underground mine. A 500-meter water drainage level is adopted as a control plant. Let us consider a procedure of fuzzy control system building in more detail. Each coordinate of fuzzy logic inference mesostructure, namely water inflow, power tariff, and pump power, are represented by corresponding linguistic variables. Membership functions to the above mentioned fuzzy sets are formed by piecewise linear functions. This reduces computational complexity while implementing a fuzzy logic inference algorithm. The linguistic variable water inflow includes three fuzzy sets: low inflow, normal, medium inflow, and high inflow. The fuzzification of the linguistic variable power tariff is performed on the basis of the following considerations. In compliance with the law of Ukraine on the electric power market, a new power cost system for industrial enterprises and distributors was established. This system involves the introduction of an hourly tariff mode where power costs change every hour depending on the market conditions. Thus, in order to formalize the fuzzy control algorithm, we differentiate the power cost in the peak, half-peak, and night zones. The output coordinate of fuzzy power consumption control system is the total output power consumed by drainage pumps. It has three membership functions: 1 pumps, 2 pumps, and 3 pumps. On completing the fuzzification phase, it's necessary to perform the rule base of Mamdani fuzzy inference system. This procedure is carried out and taking into account technological requirements for operating modes of mine water drainage. The key requirement is to ensure the efficient groundwater pumping depending on intensity of its inflow into underground mine. Therefore, the highest level of significance is given to those comprising the fuzzy set high inflow. Since the system has two inputs, the conditional part of the base rules use the fuzzy operator to establish a logical relationships between the input variables of the fuzzy inference system. A comparative analysis will be performed for fuzzy logic inference systems with and or type rule base, as well as with a system without power consumption control, in which two pumps with nominal performance and power are simultaneously operated on the level throughout the day. The system operation is modeled during a week and a month. The results of experiments are summarized in tables. The control system that uses the fuzzy logic interference algorithm with the OR type rule base provides 1.09% lower level of power cost over a week than the uncontrolled one, and this in the use of N-type rule base by 4.1%. If we compare smart expert control systems with each other, the system with N-type rule base is more cost effective. It provides 2.3% lower power cost than the system with the O-type rule base. This trend persists if they consider a longer period, for example, a month. Moreover, the level of savings on power costs is only increasing. Thus, the fuzzy system with the O rule base allows reducing power cost by 2.3%, the system with N-type rule base by 5.4%. That is, the percentage ratio increases for both systems by 0.4% and by 1.3% compared to the week operation. The cumulative nature of the economic effect is observed. At the same time, the N-type rule-based system provides 3.2% lower total cost of the produced power compared to the O-type rule-based system. Two characteristic features of fuzzy control system of water drainage power consumption at underground mines should be noted. The average power of the facilities at the mine level almost does not deviate for 6000 kilowatts during the considered period of operation. What is more, the power consumption level of uncontrolled system is lower. This is due to the fact that in fuzzy control system power it consumed unevenly, and there are long periods when the water inflow is high and three pumps are running at the same time, which leads to an increasing level of power consumption. However, the fuzzy control algorithm allows increasing economic efficiency of the system due to the transfer of the high power consumption period to the night tariff time, thereby reducing the total cost of producing power. The developed fuzzy algorithm can be applied to the controlling a peak pumped storage power plant of the mine water drainage facilities of underground mine. Thank you for your attention.